So now we're going to look at part 3 of this video series. We're going to look at simplifying fractions, equivalent fractions. We're going to look at area and other items as well. We're also going to look at, in the objectives, about creating equivalent expressions using a different denominator. And then we want to look at how we can simplify, test for equivalence with fractions, and then looking at the concept of area. So to begin, we know that with the multiplicative idea, that if we have A and we multiply A by 1, we know that we're going to get A. And so we're also thinking that A could represent n divided by n. And so we know that n divided by n would be the same as 1. So when you're looking at this, if you've got 1/4 and we want to create a different denominator of 12ths, notice that we would multiply 4 by 3 and 1 by 3 to get 3/12. You're also, you are creating equivalent fractions as well. You just went from fourths into something smaller, which was 12ths. And another way to look at that is you could have your area, and if we divide it into fourths, and we only want one of them, well, what happens when I now divide it? Notice the 3/3, 3 divided by 3. So then I'm just going to divide the whole into thirds. Well, what I want now are these 3, but out of how many total now? There's 12. So we're going from 1/4 and multiplying it by 3 divided by 3. That 3 divided by 3 is 1. That's your n divided by n. Since it's 1, it's not going to change the value of the problem. It does change the size of the equivalent fraction. So if we have 1/2 multiplied by 8 divided by 8, we're going to get 8/16. 8/16 is equivalent to 1/2. It's just it's in 16ths, so they're smaller pieces than 1/2. If I have 2/3 and I multiply it by n divided by n is 5 divided by 5, I'm creating an equivalent fraction of 2 times 5, which is 10, 3 times 5, which is 15. 10/15 is the same as 2/3. It is an equivalent fraction, and 15th is a much smaller piece than thirds. And then if we looked at 4/3 times 5 divided by 5, so 4/3 multiplied by the n divided by n, 20/15 is an equivalent fraction to 4/3. 15th is just a smaller piece than thirds. So you're looking at your multiplicative identity. That's 1. 8 divided by 8 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. So multiplicative identity, you're thinking, well, what can I multiply any number by and not change the value? And that's 1. Also looking at equivalent fractions. Well, if I have 2/5 and there's a denominator of -35, then think about what's the equivalent fraction. Well, 5 multiplied by -7 would get me -35. So what's 2 multiplied by -7 would be -14. So -14 divided by -35 is 14/35. That's equivalent to 2/5, but that's what I'm looking for, is the -14 divided by -35. And if I have part B, 3/4, and you're looking at, well, what did I multiply 4 by to get -24, and it's -6? So I've got to multiply 6 by negative 6 to give me negative 18. So see, what you're doing is you're doing 3/4 multiplied by the negative 6 divided by negative 6. It's that n divided by n which creates the negative 18 divided by negative 24. So what if I have negative 1/6 and I have a denominator of negative 6? Well, 2 multiplied by negative 3 would give me negative 6. So negative 1 multiplied by negative 3 would be positive 3. So I just need one of the numbers to be negative. Negative 1/2 is the same as negative 3/6. They still have to stay equal. We're still looking at equivalent fractions here. All right. Another one is simplifying fractions. So we think about factoring. We've already talked about factoring the numerator and factor the denominator. You want to identify those common factors and then remove them or divide them out to get a value of 1. So in this case, you look at 6/8. Notice we just factored 6 into 3 times 2, and 8 was 4 times 2. So what's in blue here are the two factors that are the same. You can divide those out and you're left with 3/4. So let's do that with some of these. So if negative 8/20, I can think negative, let's see, I know it's a negative 1, and then how about 4 multiplied by 2? And 20 would be 4 multiplied by 5. So here's where I could divide these factors out, which would give me 5 in the denominator, but negative 1 times 2 would be negative 2/5. So negative 2/5 is just the simplified version of negative 8/20. Let's look at 14/24. Well, factors of 14 would be 2 and 7. Factors of 24 would be 2 and 12. So you're always trying to look for ones that they have in common, and they do. It's right there. So these would divide out, leaving you with 7/12 as your simplified form. And then let's look at negative 50/30. I see that that's negative 5 multiplied by 10 and 3 multiplied by 10. So we've broken it down into the factors that we see that will divide out. And this becomes a 1, so you're left with negative 5/3. Here we're looking at comparing fractions. And in this case, what I'm going to ask you to do is think about if you were going to get common denominators. Well, let's say 30, okay? I know it's not the lowest, but if we said 30, then what you're trying to do is you're looking for your n divided by n. Well, that would be multiplied by 6 divided by 6. Notice what you just did here. You just did 5 times 6, which we also see is right here. So that would be 18/30. Well, if we wanted to make this 10 a 30, right, then we've got to multiply by 3 divided by 3. Well, notice here, and what you did here, that's 10 times 3, which is 30. So I'm also going to get 18/30, and we know that those would be equal. So notice what you did. You multiplied 10 multiplied by 3, and 5 was multiplied by 6. So look at this in a diagonal way. We know that we multiplied 10 by 3, and we know we multiplied 5 by 6. So that's another way to look at it, is looking at your cross products and see if they're equal. But a lot of that comes to the forefront if we're thinking about trying to create a common denominator. So here we could look at comparing, and in this case, with some of the problems that I give you, I would just want you to be able to show me that you can check. So this is a negative 10 times a negative 12. Well, that's going to be a positive 120. And then 8 times 15. Well, that's 80 and 40, and that's also 120. So yes, these are equal. Next, 9 times 2 is 18. 6 times 3 is 18. 18 equals 18. Check. 2 times 20 is 40. 3 times 14 would be 30 and 12, which is 42, and they are not equal. 8 times 6 is 48. 16 times 3 is 48. So yes, those would work. So there's you some practice. If you're going to look at comparing fractions, you can look at the YouTube videos and the links. Again, we want to look at our last objective here, solving problems looking at area. So Charlie's Landscaping used 2/3 pound of peat moss when planting a rose bush. How much does he need to plant 21 rose bushes? Well, here we notice that if it's 2/3 of a pound for one rose bush, then if for 21 rose bushes, we would do the multiplication here. But remember, we can write 12 as a ratio compared to 1, which gives us a better view of, well, this is going to be 21 times 2, which would be 42, and 1 times 3, which would be 3. And 42/3 is we'll divide by 3/14, so that's why we see 14 rose bushes. So again, when we're trying to simplify, we can see that we've got 2/3 multiplied by, well, let's change 9 to 3 times 3, and let's change 4 to 2 times 2. And we could use the commutative property and switch around some of these. So I could make it 3 times 3 divided by 3, and 2 in the numerator and 2 times 2 in the denominator. So now we can see, well, those will divide out and those will divide out. So I'm left with 3 divided by 2. 3 in the numerator, 2 in the denominator. If we look at this one here, 32 times 7/8, 32 to 1 multiplied by 7/8. Well, 32 I could simplify into 8 times 4. And then if I wanted to use commutative property here, that would just give me 8 times 4 divided by 8 times 7 divided by 1. These will divide out. So what would happen is you'd have 4 times 7, which would give you 28 as a result. All right, so now let's look at area. So when we're dealing with a rectangle is just going to be your length times your width, or your base times your height. But if you're dealing with a triangle, you're just dividing all that in half. That's why you see the formula as base times height, all divided by 2. So if I take half of that rectangle, I'm going to get the triangle that I desired. So here's your formula that you want to put to memory, and that's your area of a triangle, is your base times your height, and then divide that by 2. So we also have to identify our heights. So in the green triangle, we notice that 15 is our base, and 8 is our height. And we want to divide it all by 2. Well, remember, we can take 15 and we can take 8 and make it 4 times 2, and then all divided by 2. So these 2's will divide out. So 15 times 4 is 60 square inches. That's what we're dealing with in area. on the red triangle, we see the base is 40. So we would say area equals the base multiplied by the height of 18, all divided by 2. So we could look at 20 multiplied by 2 multiplied by 18. When we divide it by 2, this would disappear. So we would have 18 times 2, which would be 36 times 10, we would have 360 square centimeters. Here we're looking at the base, which would be 20. The height would be 12. We just need to make sure to divide that by 2. So then we can also look at, well, will 2 divide 20? Yes, it'll divide 20 10 times. And then 10 times 12, we would have 120 square units if we're looking for area. Over here, I know the base. The base of the entire is 14. And we know the height, and we need to divide all that by 2. So the base would be 14 multiplied by the height, all divided by 2. So 2 will divide 14 7 times. So 7 times 5 is 35 square units. And that's your area. If we want to look at area of irregular shapes, you may want to look at how you can subdivide. And if we know that this is 12, and we know that this has to be 8, if I can draw a perpendicular line here. So we know this is 12. So what's 12? What's 12 multiplied by 8? And then we want to divide that by 2. So half of 12, 2 will divide 12 6 times. 6 times 8 would be 48 square units. That's the area here. And then we know that we've got a 12, not drawn to scale, but a 12 by 12, which would be 144 square units. All right, so there's some more practice if you want to look at finding area of triangles or irregular shapes or any other additional videos. And so our last push on this part 3 is to look at reciprocals, solving equations using the reciprocal principle. And so we think about, how do we find the reciprocal? Okay, well, what is the reciprocal? And that's going to be when you look at a number and you invert it, if you take 3/4, then the reciprocal would be 4/3. You're just going to interchange the numerator and the denominator. And it's helpful with division. So if you're looking at division of fractions or whole numbers by division, you can certainly use the reciprocal method to do that. So when we take 3/4 divided by 1/8, we are thinking, as I said here, how many 1/8 will divide 3/4? Well, if we create an equivalent fraction to 3/4, then I just need an n divided by n, which would be 2 divided by 2, which would give me 6/8. Now we can think, well, how many of those little 1/8 pieces would fit into 6/8 pieces? And the answer would be 6. You can also look at that as, well, what's 8 divided by 8? Well, that's 1. Well, what's 6 divided by 1? Well, that's 6. So the answer is 6. And you can do that when you have the same denominators with your fractions. Or you can use the reciprocal. Now, if I gave you 10 and asked you to divide it by 5, you would tell me it's 2. But if I said 10 multiplied by something is also 2, then you would have to think, well, 10 multiplied by something to get to 2, that number, is pretty small, so I'm having to divide to get smaller. So what you're going to find is that you are multiplying by the reciprocal. 10 multiplied by 1/5 is the same as 10 divided by 5, which is 2. So if you want to change from division to multiplication, you're just going to use the reciprocal as part of that process. So if I have 5/6 divided by 2/3, one way to do this is let's make 2/3 equivalent to 6. So that would be 4/6. How did we get that? Well, we picked our 2 divided by 2. So that would be 4/6. Now what's 6 divided by 6? Well, that's 1. What's 5 divided by 4? Well, it's 5/4. So 1 1/4 or 5/4 would be the result of dividing those. And then let's look at this one. We've got -3/5 divided by 1/2. Well, we could use the reciprocal rule on this one. We could say -3/5 multiplied by the reciprocal, which would be 2 to 1. And that answer would be -6/5. So a couple methods there when you're looking at dividing fractions. You can use the reciprocal rule, or you can look at getting a common denominator. So if you had something like this, 2/3 divided by 1/4, well, I can't really make fourths into thirds and thirds into fourths, so I'm going to look for an LCM, a lowest common multiple, which would be 12. But I've got to think, to get 12, what's my n divided by n? Well, it's going to be 4 divided by 4, which would give me 8/12. Now I've got 1/4. What am I going to multiply as my n divided by n to get 12? And it's going to be 3 divided by 3. So 1 times 3 is 3, 4 times 3 is 12. So now you can look at the denominators. What's 12 divided by 12? 1. What's 8 divided by 3? 8/3. So we would say 8/3 is our answer. And then this is just one more way to look at division of fractions. Is this one right here is no different than 5/6 divided by 2/3. It's the same thing. It's just this, the method that we're looking at with these four is that these are what we would say complex fractions. So if we had -3/5 divided by 1/2, we could say -3/5 multiplied by 2 to 1 and multiply to get -6 and multiply to get 5. So -6/5. So there's some practice on reciprocals, multiplying by the reciprocal, especially if you're in division of fractions and you want to multiply, then you would have to change the divisor and take the reciprocal of it. And here we want to look at solving equations with multiplication. So here we've got Benny uses 2/5 gram of toothpaste each time he brushes his teeth. So 2/5 toothpaste every time he brushes his teeth. Benny uses a 30-gallon or 30-gram tube. How many times will he be able to brush his teeth? So that's what X is representing. X is representing how many times he brushed his teeth. But if he's using 2/5 of that each time, and he's got a 30-gallon tube, we're just trying to figure out, well, how many times can you brush your teeth till you run out? Well, one way to do this is to just divide by 2/5 on both sides, because 2/5 is the coefficient. Well, this would go to 0, so you're left with X equal 30 divided by 2/5. Well, remember, we can get common denominators, or we can multiply by, and the reciprocal of 2/5 is 5/2. 2 will divide 30 15 times. 15 times 5 is 75. So he can brush his teeth 75 times if he's using 2/5 of a gram when he's got 30 grams. And another way to look at that is you could do 30 divided by 2/5. And we can make the 5 a 1. Just my n divided by n would be 5 divided by 5, which would be 5 times 30 is 150 fifths divided by 2/5. So 5 divided by 5 goes to 1, and here we're trying to figure out, well, what's 150 divided by 2, and that's going to be your 75. Another example is we got 3/4. Basketball shorts require 3/4 of nylon, so how many pairs of shorts can be made if you're dealing with 24 yards of nylon? So you could also multiply by the reciprocal on both sides. So that's 12 divided by 12, so I'm left with 1x. And then here, remember, we can break down the factors if we need to. So 8 times 3 times 4, all divided by 3. Well, these will divide out, and you're left with 32 pairs of shorts. Another way to look at that problem is 3/4 x is equal to 24. If you wanted to divide by 3/4 on both sides, now you would have 24 divided by 3/4, which is the same as 24 multiplied by 4/3, which is what we had over here. So if Kristen makes an 8-foot submarine sandwich, each person receives 2/3. Each serving is 2/3 of a foot. How many servings does Kristen's sub contain? So you're thinking, I need to get 2/3 into that piece there. So that could be trying to get a common denominator. We'll look at both methods. Trying to get a common denominator, I'm just going to multiply this by n divided by n, which would be 24/3. That's the same as 8 divided by 2/3. Well, 3 divided by 3, well, that's 1. And 24 divided by 2 is 12. So you could have 12 servings using this method of 2/3 of a foot for each serving. Okay, so based on what I have here is when solving equations and the coefficient is a fraction, you can multiply by the reciprocal on both sides of the equation. So here, if it's a one step, I see 3/4, I'm going to multiply by the reciprocal, which is 4/3. Well, remember what happens here, that's 12 divided by 12, which is just 1x. This 15 times 4 is 60, and 60 divided by 3 is 20. And then let's look at 4/15 x is equal to 12/25. So if I multiply by the reciprocal on both sides, that goes to 1, which is what you wanted. Now, 12, 15, 25, and 4. So if I took 4 times 3 times 5 times 3 times 5 times 5 and 2 times 2. So now we start to look at what would divide out. Well, the 5s would divide out. This 2 times 2 and this 4. So I'm left with 3 times 3, which is 9, and 5, which is 9/5. And then we'll just look at one more. So if I have 3/4 x is equal to 12, well, I could multiply by the reciprocal, which is 4/3, and I would just do that to both sides. So this is 12 divided by 12, which is 1x. Now, that's a whole number multiplied by a fraction, remember. So what we're going to have here is 48/3, or 16 is your answer. So there's some more practice if you need to on solving equations with reciprocals, and that's going to conclude this part 3 video series where we were looking at reciprocals, solving equations, the multiplying effect, and that concludes this video.